Good morning to all the students. Students, this lesson is for class 10th for the subject of chemistry, topic relative atomic mass, which is covered in chapter 5, mole concept and stoichiometry, starting on page number 76 of your textbook titled Concise Chemistry by Selena Publication, and is being submitted to you on 12th April 2021. This voice is of Mohinisha Thakur. All students may now please open page number 76 of your notebook in front of you. If all students are ready, then let us start with this chapter. All students may now please listen carefully. Relative atomic mass. Relative atomic mass or atomic weight of an element is the number of times one atom of the element is heavier than 1/12 times of the mass of an atom of carbon 12. Atomic mass is expressed in atomic mass unit, which is AMU. Now, there is another term which is the relative molecular mass. So, students, the relative molecular mass is obtained by adding together the relative atomic masses of all the atoms present in a molecule. Example, let us find the molecular mass of NH4 whole twice Cr2O7. This you may observe on the page number 2 of the notes, which is sent on 12th April 2021. For this, to find the relative molecular mass, we have to know the atomic masses of all the elements in the compound. So here you may observe here that in first we have to find the relative molecular mass of NH4 whole twice Cr2O7. So here the atomic mass is given to you. So nitrogen has 14, hydrogen has 1, chromium has 52 and oxygen has 16. So through this atomic masses of each element present in this compound, we will calculate the relative molecular mass. So what we will do here, put the nitrogen's atomic mass, that is 14. Now we will also multiply it with 2 because the 2 is out of the bracket. So this 2 will multiply each of this element present in ammonia, that is nitrogen and hydrogen. So it will 14 into 2 plus hydrogen have 1 atomic mass. So 1 into 4 2s are 8 plus chromium have 52. So 52 into 2 because chromium has 2 atoms. So we will multiply the atomic mass of chromium with 2 plus now 16 atomic mass is of oxygen. So we will write 16 here and multiply it with 7. So that will be equal to calculate will come 252, right? Similarly, the second one is CH3COONA. For this, each element atomic mass has given to you. Here you may observe that carbon has 12, hydrogen has 1, oxygen is 16, sodium is 23, right? So put these atomic mass in this compound. So 12. So we will not multiply it with any number because carbon has only 1. So 12 into 1 is 12, right? Plus 1 into 3. Then plus 12 plus 16 plus 16 plus 23 is equals to 82. Now we will do gram atomic mass. So students, the atomic mass of an element when expressed in grams is called gram atomic mass. The atomic mass of sodium is 23 AMU. Its gram atomic mass is 23 gram. So 1 gram atom of sodium is equals to 23 gram of sodium. Now we will discuss the gram molecular mass. The molecular mass of a substance expressed in grams is called gram molecular mass. Now move on the next topic, which is mole. So if I say 1 dozen banana, you know that means 12 bananas. A gross means a collection of 144 objects. In the same way, 1 mole means 6.02 into 10 raised to the power 23 particles. Atoms are very tiny particles, therefore we use mole for them. We generally use mole for atoms and molecules. So 6.022 into 10 raised to the power 23 is called as Avogadro's number. Now we will discuss the important relations. So students, let us start with this. So 1 mole oxygen atoms is equals to 6.022 into 10 raised to the power 23 atoms, that is of oxygen atom. And 1 mole of oxygen molecules is equals to 6.022 into 10 raised to the power 23 molecules, that is O2 is a molecule, right? Then 1 mole water is equals to 6.022 into 10 raised to the power 23, that is H2O molecule. And 1 mole of ammonia, that is equals to 6.022 into 10 raised to the power 23 NH3 molecule. So mole can be used for atoms and molecules. 1 mole atom is equals to 6.022 into 10 raised to the power 23 atoms, that is equals to gram atomic mass. Therefore, 1 mole oxygen is equals to 6.02 into 10 raised to the power 23 oxygen atoms is equals to 16 gram. And 1 mole of nitrogen atom, that is equals to 6.02 into 10 raised to the power 23 nitrogen atoms is equals to 14 gram. And 1 mole molecule is equals to 6.02 into 10 raised to the power 23 molecules, that is equals to gram molecular mass, or you may write as GMM. Therefore, 1 mole oxygen molecules is equals to 6.02 into 10 raised to the power 23 molecules of oxygen is equals to 32 gram, which means 16 into 2, that is equals to O2, because oxygen have 2 atoms, so we will multiply the 2 with the 16 and it will become 32 gram. Right? And 1 mole water molecules is equals to 6.02 into 10 raised to the power 23 H2O molecules, that is equals to 1 into 2 plus 16 is equals to 18 gram. 2 moles of water is equals to 2 into 6.02 into 10 raised to the power 23 molecules of H2O, that means that is equals to 2 into 18 is equals to 36 gram. Right? If the substance is a gas, then 1 mole is equals to 22.4 liter at STP. STP stands for standard temperature pressure, that we have discussed it in the previous lessons, right? So 1 mole, that is equals to 6.02 into 10 raised to the power 23 molecules, that is equals to GMM, that is gram molecular mass, is equals to 22.4 liter at STP. So 1 mole oxygen molecule, that is O2, is equals to 6.02 into 10 raised to the power 23 molecules. That is equals to 32 gram and is equals to 22.4 liter of volume at STP. We can also say that 22.4 liter of O2 gas is equals to 1 mole, that is equals to 32 gram. So 2 moles of O2 is equals to 32 into 2, that is equals to 64 gram, is equals to 2 into 22.4 is equals to 44.8 liter at STP. Now we will start with numericals. So number 1 is find the number of molecules in 16 gram of oxygen gas. So here we will find the number of molecules of 16 gram of oxygen gas. So oxygen gas contains O2 molecules and mass of O2 is equals to 16 into 2, that is 32 gram, and GMM, that is a gram molecular mass, is equals to 1 mole is equals to 6 into 10 raised to the power 23 molecules. So here therefore 32 gram is equals to 6 into 10 raised to the power 23 molecules. Okay, so 1 gram, we will find the 1 gram, that is equals to 6 into 10 raised to the power 23 molecules, and the 32 will come on the divided side on denominator. Then we will using a unitary method. So therefore 16 gram is equals to 6 into 10 raised to the power 23 upon 32 into 16. We will multiply it with 16 because we have to find the 16 gram of oxygen. So 16 in 1 the 16, 16 to the 32, and it will become 2 will cut with the 3, 2 3 the 6, and it will come as 3 into 10 raised to the power 23 molecules.